Hey programmers, welcome back. Before we dive deep into the specifications and some of the best practices of HTTP caching, let's first define why caching is so important for us. Well, first of all, it's gonna make your website or web app much faster because you're not gonna make this unnecessary call to the server anymore to download this asset. And the second reason is that your users are usually using mobile data and they're paying money for that mobile data. So imagine a user has to download the same heavy asset, let's say an image of 200 kilobytes every time they refresh a page, and they're gonna be paying some money for that image. So in order to save them money and not let them download this image over and over again, you can use caching. And now let's get deeper into the topic. Alright, so this is gonna be our diagram and I'm gonna try to make it visual for you so that it's much easier to understand. So let's get started. When we talk about the client and server relationships in terms of caching, just keep in mind that client is not always the browser, although it is most of the times, like 99% of the times. What I mean is by that, there are some other devices, embedded devices that don't have a browser but still make requests to the server and might have caches. But to make our life easier, just imagine that we're talking about web development and it's always a browser that makes a request to the server, all right? One other entity is obviously a server that's gonna send us the assets back to the browser, be it in HTML, CSS files, any JavaScript file and so on, or some media files, videos and so on. And we also have some intermediary entities like reverse proxies or CDN. I'm going to talk about the CDN in just a bit, so please bear with me. Next, we're also going to talk about directives. They are very important when it comes to how the cache gets validated and so on. But first thing first, I want to talk about hits and misses because this is the bare minimum of caching that one has to know. So I'm going to switch to a pen and imagine we have a browser and this cache is the browser's cache. That's why it's so closer but to the browser than to the server. So when a browser is parsing an HTML file, and let's say it finds a script, so a JavaScript, or let's say if it finds an image file. So it needs to download this image. So first it's gonna check this image in its own cache and ask the cache if the cache has this image. If it does have this image, then it's going to return this image back and we're going to call this a hit because it hit the cache and cache made sure that the image version is fresh and can give it back to the browser. So the browser is going to reuse this image from the cache. But what is a miss then? Well, a miss happens when we request something from the cache and cache either says that this file never existed in the cache or that it simply gets flushed because the age of this file expired. So the cache tells you to fetch a new one. And then we're gonna simply go to the server and fetch this data, or in our case, an image. And the server is gonna give this image back to the browser, and the browser is then probably gonna store it in the cache, depending on what the server tells the browser to do. Well, now you know more about hits and misses, but one thing to note here is that you as a developer don't have much control, especially as a front-end developer, you don't have much control over what you're gonna store in your browser's cache and whatnot, and especially how to clean it. Well, the reason is when the server is sending files back to the browser, it can also send some headers. So the browser is automatically gonna parse those headers, and based on those headers, it's gonna store the files in the cache. So in the code in JavaScript, you have no control over this. Maybe one thing that the user can do is simply to clear their browser cache, but it's a different topic. So what I want to say is that there is no specific API for working with a cache on the browser, on the client side. Now let's go back to our diagram. And before that, when I mentioned that the browser sends headers that define how the cache is going to store it, what I meant is basically this. As you can see, we are on Cloudflare's website, and apparently the user requested an HTML file from Cloudflare, and Cloudflare returns some headers. One of them is cache control. And cache control defines how this entity or how this file is going to be stored in browser's cache. In our case, it also sends some directives or attributes, so to say. One of them is public and another one is max age. We're going to go over directives, as you can see here on the right side, in a bit, but this is how it usually looks like when you open your DevTools in the browser and inspect an element that you just downloaded. All right. So going back to our diagram, what do we have here? We have a browser that makes a request. So this request goes to the server, but we can also have some intermediary entities. One of those cases is a CDN. What is a CDN? CDN stands for Content Delivery Network. I'm going to draw something to make it easier for you. Imagine you are a user somewhere in Asia, all right? So let's say this is you, and you are requesting some data. And the origin server that is supposed to send you this data back is sitting in, let's say, in North America. So obviously there's some distance between Asia and North America. What a CDN or a content delivery network can do is that it can be deployed somewhere in between, let's say somewhere in Europe. It can also be deployed somewhere in Australia, and one of them can also be deployed somewhere in Asia. And it's gonna kind of act as a cache rather than a proxy. Well, when you see a proxy here, a reverse proxy, or rather a CDN, is kind of a type of a reverse proxy. And CDNs serve two main purposes. First of all, they are very good with caching and invalidating that cache for the users. And the second reason is that they are usually globally distributed across the world, across different continents, so that if you are a user in Asia, let me change the color. So you are here in Asia, and obviously the server is far away in North America. You're probably gonna go grab this data from a CDN instead of going all the way to the origin server, because they have the same data here. So, and depending on your location, if you suddenly change your location and you're in Europe now, then you can simply go to this CDN instead of going to this CDN. CDNs are basically leveraging the location. So you're usually going to go to the CDN that is closer to you. All right, so it's just a proxy. And now let's see what directives we have here. So first of all, max age. It's the one that you would usually see more often. As you can see in this image above, we also set a max age, and we also set some value on the right hand side. What this value is a number of seconds. In this case, 14,400 seconds. Okay, but what do these seconds do? Let's take a look. So I'm gonna simply clear all of this. So when a browser requests some data from the server is gonna respond, as we understood, and it's gonna set some max age. And it's gonna set this max age obviously in this cache control header, okay? So all the directives here are related to cache control. Don't forget that. So till here, these are the directives. I'm gonna talk about pragma expiration very soon. Very soon. So the server is gonna send some data, and let's say it has max age. So max age basically means that this is the maximum time that the asset is able to be stored in the cache. So when the time actually goes beyond this max age, the cache is simply going to get rid of it. So it's basically like an expiry date on a bottle of milk, you know? So it works pretty much the same way. And if it doesn't exist in the cache anymore, then the next request, the browser is going to go straight to the server instead of the cache. We're going to talk about this max age in just a second. So the next one is no store. What is no store? Directives like no store, no cache, must-revalidate are very confusing, and I really understand that, but I'm going to try to do my best to explain it to you because they're very important. So no store, as the name probably suggests, means that you shouldn't store any data in the cache. So when the server responds with no store attribute, what it means that the browser should not be storing it in a cache in any way. What are some use cases for using this attribute? So imagine you're a banking software and you obviously don't want to cache the amount of money that is left on user's account, because then you would have some stale information. And obviously you always want to be up to date on how much money a person has. So don't store sensitive information in the cache. And second use case is when the server responds with an HTML file, it's a really bad practice to cache HTML files, because HTML file is like an entry point for our application and it holds references to other assets like our styles, like CSS files and JavaScript and so on, and images. So HTML file should never be cached, and it's a good practice to send this no store attribute with an HTML file. Well, the next one is no cache. And what no cache is? Well, no store, no cache sounds kind of similar, right? So what no cache means is, imagine we again serve some file from the server and we save it in a cache. And then the browser wants to make a similar request to the same file. It means that there's never gonna be a hit when we have a no cache directive. So it's always gonna go first to the server and then ask for the server for a file. So it's basically omitting the cache, and doesn't matter if this file was already there or not. It's always gonna omit the cache and it's gonna always miss. Okay. And the next directive that we have here is must-revalidate. What must-revalidate does is, whenever the browser goes to the cache to ask for the specific asset, it simply makes sure that you're never gonna get a stale response from a cache, no matter what the circumstance is. Imagine you did some magic there and the cache is still somehow able to give you stale information. Must-revalidate means that it's gonna make sure that the file in the cache is always fresh. That's why must-revalidate is usually used together with max age, so that must-revalidate is able to see whether the max age has been passed or not, okay? All right, the next one is public and private. This is very easy to explain. Basically, when a cache control header, as you can see here, has this public value, it means that the origin server allows the file to be cached on CDNs or reverse proxy or anything in between. When we have a private directive, on the other hand, we are allowed only to store this cache on the client, so only in the browser's cache. So why is it important? It's important to, first of all, to notice that CDNs are usually public, so it's not your private, and you should never store very sensitive information there. Otherwise, it's going to be a security flaw. All right, if this is clear, we can move on. So immutable, stale-while-revalidate, stale if error. These are also pretty interesting ones. So immutable basically means that the asset that the server gives to the browser is never going to change, and it can leave it in the cache for as long as it can. It's basically the same as max age, and the maximum number for max age is 1 year. So I would personally never use that. It's quite risky, but the next two ones are also interesting. So stale-while-revalidate. Do you remember how in no cache, we are always going to revalidate? So we're always going to go to the server and ask the server first without going to the cache. Well, what stale-while-revalidate means that you're able to get the stale version of the data. So you can go grab this data from the cache while I'm revalidating it from the server. So let's say revalidating takes 5 seconds and you still have some data in the cache for the same object, of course. You're going to take this file from the cache and show it while we are fetching the fresh one from the server for 5 seconds. I'm not sure when you would want to use this, but it's kind of a fallback, so to say. And we also have stale if error. Imagine if we go to the server to fetch the data that we want to revalidate, and if the error happens, we're simply going to serve the one from the cache, even if it's stale. So these are kind of interesting fallbacks that you might also want to keep in mind. All right, these two are also, although three. So pragma is a very outdated header. It's almost never used unless you want to support really, really old browsers. Same with expires. Nowadays, you only use max age and shouldn't be using expires. Although if you want to support old machines, go for it. It's mostly used for CDNs to define different user agent specific settings. For example, the browser language, because some operating systems are not always in English. It can be in Italian, in German, or whatever. And then you want to kind of track that by a public CDN and then serve only the data that is matching the user agent's vary. And there are different attributes like accept language and so on, but I'm not going to dive deep into this. Instead, I'm going to link a video in the description so that you can check it out. All right, now let's go into a bit deeper and let's see what happens. So we're talking about heuristic caching. What's going to happen if you don't supply cache control? So in this example, we have cache control and some directives. But what happens if you don't have it? Well, then modern browsers are gonna still cache it. Yes, they're gonna still cache it and they're gonna use this heuristic caching. What they're gonna do is they're gonna look at different headers, for example, last modified, and they're gonna calculate the difference between the current date and last modified. And now let's say we are in 2023 or 22, and it's been last modified in 2021. So there's 1 year gap or 1 year difference. And modern browsers are gonna still cache this asset, but for only about 10% of this time span that has passed since it has been last modified. So it's still gonna cache it, very similar to a max age. And it's gonna set the max age to, let's say, 1.5 months, because it's like 10% of one year. It's not gonna be max age, but it's gonna save it heuristically somehow. All right, next point is if modified since. So when you look at this part, this is basically the response headers that the origin server is responding to the browser. And it's responding with obviously cache control with max age, last modified, and date, and so on. But did you know that we can also send cache related headers when we make request? So if you open your developer tools and inspect one file that is in the network, you're gonna see that we have request headers and response headers. So this is a request header. And the way we are telling the origin server to send us a new file or not is by sending this header called if modified since. And we're sending the data that we're taking from here. And if the server sees that, yes, the modified data is newer than the one the client sent, then we're going to send the client a newer version because we have something new. But this led to a lot of issues when it comes to time zones, because it's really hard to manage time zones. If you don't believe me, I'm going to link a video of Tom Scott who talks about this issue in a very interesting video, so please check it out. And people came up with this other idea of ETags and if non-match. So ETag is basically the same as last modified, although it's not. It doesn't give you back the date, but it gives you back some kind of a hash or an ETag. Let's say this is our ETag. And then what we're gonna do is simply upon making a request to the server, we're gonna supply the same ETag in this header, if non-match, and we're gonna send the same header. And now the server can compare this ETag to the one that it sent previously. If the ETag doesn't match, then it's gonna know that the file has been changed and I have a new version, so I'm gonna send you, the client, a new version. You could ask, like, how does the server generate this ETag? Servers are free to choose the way they generate an ETag, but the very common way is simply by taking the contents of a file and hashing them. The way they do it is basically, if there's a change in the contents of the file, then the new ETag is gonna be generated. If you're a Node developer, if you're a JavaScript developer, there's a package called ETag on npm, which can do that directly. Nowadays, CDNs are so mainstream and CDNs are used everywhere for assets that has to be cached. So you don't usually need to worry about ETags. They're doing it automatically. And the last technique is cache busting. And it's also very, very common. Let me tell you what it is. All right, let's say you have a React or Angular application or from some other framework. Whenever you build your app, it's going to spit out some files into the dist folder. And probably one of the files is main.js. And it usually has this hash in the name. Let's say main dot some random hash and .js. Have you ever wondered why this hash is in the file name? The reason is whenever we deploy a new version, this hash is going to change. And it's basically going to be a new file with a different name. So we're basically making sure that our assets are revalidated and they never go to the local browser's hash or cache, and CDNs never serve us a stale version because we're essentially requesting a completely different file. And by using this technique, you can always make sure that your users always get the changes that you push on your development server. Obviously, this is good for dynamic content, and everything else that we have discussed above is good for more or less static content like assets, images, styles that rarely change, and so on. All right, guys, I hope you enjoyed this video and learned something new. If you're still interested in similar topics, make sure you check the playlist of software development topics videos, and I'm gonna see you in the next one. Goodbye.